So the crankshaft is going to spin in these little V blocks right here. So we don't want it spinning dry. So we put a little it's called lubriplate number 105. This is the only grease that we use for balancing, and it's put out by Napa. So, and it works really good. Put a good coating of this on both V blocks. And we're ready now to set the crankshaft up there. Crankshaft has little oil holes in it, so you've got to straddle the V blocks with the oil holes, that's all good. So we are ready to bolt on our bob weights. So I always number my bob weights. This one here is bob weight number 1. I always put it on 1, 2, 3, 4. And the reason I do that is if I ever had to take them off for whatever reason, I want to put them back on the same journal that they came off of. Sometimes you have to take them off and maybe weld up a hole in the crankshaft, or you've got to drill a hole and add some heavy metal. But it's always important to get those bob weights back in the same, trying to duplicate what you've already done when you balance it or spin it a second time. So bob weights go on like this. They go 90 degrees on the rod journal. So basically, I use the center line of the crankshaft and I put it 90 degrees. I mentioned earlier it's 10-10 now. In other words, that means the rods have been 10 turned under and the mains are 10 under. Now this particular one, the reluctor wheel is a 24 tooth reluctor wheel, which is an earlier model, like 2004, 2005 back, LS 5.3. We got bob weight number 2 going on. Again, it goes 90 degrees on the journal. The blocks, the bob weights, the blocks are made of aluminum, so they're soft and they don't damage the crankshaft journal when you're putting them on and spinning it. So because they're a lot softer material than the actual crankshaft itself is. These LS cranks are actually steel cranks. They're good crankshafts. Okay, center line, we're 90 degrees. Tighten it up good. Again, you don't want one of these coming off as you're spinning. All right, ready to go to number 3. And next one, and the last one is number 4. Make sure we're centered up on the oil hole. Make sure we're 90 degrees. Everything looks good. So earlier, when we did our introductory video about balancing crankshafts, we mentioned that there were two types of balances. There was an internal balanced or an external balanced. This particular shaft and all LS shafts are what we call internal balanced. So they require no balancer and they require no flex plate or flap wheel. Everything is done, all the work and balancing is actually done on the crankshaft itself. So what I've done right here is I put a bolt in the front of it, which would be normally where that would hold the balancer on there, but I've got the bolt in there so I can get my probe. This magnetic probe fits on this bolt right here, and that's where it picks up its vibrations and its signal to send to the computer to tell how much out of balance it is. So we've got that ready to go. So we've got our probe attached, got it centered up good. Everything's tight. We'll check our oil holes one last time. That one looks good. Oil holes all look good. So basically, everything is almost ready. We're going to go ahead and now, this is the belt. This is the belt that hooks the electric motor down here to the crankshaft that actually makes it spin. Once we turn the power on, it's what makes it spin. And I always make sure that my belt is centered up on the main, because I don't like it rubbing on each side. I'm pretty particular about that. There we go. So we're centered up good on that. So we're going to do some measuring now on the crankshaft and put some numbers in the computer that tells it. So this will aid in helping the computer to know how many RPM it needs to spin based on the size of the mains. So the first measurement we want is bob weight to bob weight. All right, bob weight to bob weight, we're 18.25. So we're going to put in 18.25. And then it wants to know the left plane. Well, basically the left plane is where you're going to be drilling at on the counterweight. Okay, so we're about 1.5 inches. Inch and a quarter. So that's 1.25. That's good. So now we're going to want to know how far it is to where we're going to be drilling on this end, and that is 17.50, which is what we have. So we're good. Everything is good to go. Now we're going to go in here and we're going to set the RPM that we want to spin at initially. In other words, the first spin RPM. I set it at 300. Now, that 300, the machine calculates that to be about between 3,000 and 4,000 RPM on its multiplication factor. The next thing I'm going to set in here is the crankshaft main bearing diameter. So stock LS 5.3 is 2.548. We've been ground 10, so we're going to be 2.538. So we're going to put in 2.538. And that is our crankshaft diameter. So basically, we're ready to go. I've got everything punched in the computer that we need. Belt set up, bob weights are set up, the probe's on it, the engine, the electric motor is fired up and ready for me to hit the button. So we're going to do a first spin real quick, just to kind of see where we're at. So without any further ado, here we go. First spin coming up. So we've done all that measuring and weighing and setting up basically to get to this point right here. This is where we're actually spinning the crankshaft to find out where the out of balance is at. And again, we're spinning about 300 RPM on the machine, which is equivalent to about 3,000 in your vehicle or in the engine. So, first spin, not bad. We're out 33 grams on the left, 29.88 on the right. Now comes the big question. Can we remove? Yes. Plenty of room to remove material here. And plenty of room to remove material here. So this crankshaft will be pretty easy to balance. What we'll do is after lunch, I think we'll get on here and start drilling and get this thing balanced. But initial spin looks good. Left side, which is the flywheel side, we're out 3.56 ounces, which is equivalent to 33.72 grams. On the right side, which is the balancer side, we're out 3.16 ounces, which is 29.88 grams. So this crankshaft is in a remove weight status. Instead of adding, we can remove, which is a much simpler process. So we're going to get on that right after lunch.